Hey, Connor.
Hey, how are you?
I'm doing good. How about you?
Pretty good.
Okay, so Connor will speak to us about collocations and side effects and state updates with supercharged useReducer. So another really nice talk about state management, I see. So Connor, stage is yours. Thank you.
Okay, cool. Just 1 second.
Okay, I see that we have some issue with Connor. Maybe he lost his connection. So he will be joining shortly. Well, in the meantime, let's remember that we will have in November, we have 2 awesome conferences that are coming. So this cross-platform developer summit and Python Universe. And in early December, we have this Node.js case study. If you would like to take part in it, just use our React Lucky code and you will get 20% discount. Okay, Connor is back.
Sorry about that. I just had to quit the sharing.
No problem. So go on.
Cool. Okay, so yeah, I'm going to talk about collocating side effects inside of a reducer. Essentially bridging asynchronous actions and kind of pure functions of action and state together instead of just kind of littering our render components with useEffect. So, first of all, who am I? Yeah, I'm Connor Hastings. In the physical world, if there is one, still Connor on Twitter and GitHub. I've been experimenting with recurrent neural networks, and I have a Twitter bot that tweets based on the history of my own tweets called Am I Still Connor? If you're interested in that. But mostly I'm just a front-end full-stack engineer, mainly focused on kind of data management and performance within React and JavaScript. So most people think, yes, like useReducer is pure. We can't really mess with that, or it will kind of mess with the whole rendering paradigm. And that's not something that we want to do at all, and it's not something that we're going to do. So there's a quote I made up this morning. Sometimes to follow the rules, you have to still follow the rules, even if it seems like you're breaking the rules. So just to take a step back for a second and kind of get the key points of the talk across. What is collocating? It's kind of like grouping together things that are naturally belonging together. So if you think about the earlier talk with the style sheet object right inside that component, because the styles are directly tied to that component. And with GraphQL, you see like the query often in the component file itself or imported. These other things that are very tightly coupled together. But with the reducer, we kind of lose some of that because we'll fire off an action that might set like a Boolean flag or something in our state that will then like trigger a useEffect to then make an asynchronous call. And then we can end up with like multiple of these in the same component, and it just can get really, really, really messy. So yes, that's where side effects kind of come in. A side effect is just a function that will modify the state via direct mutation or something that kind of interacts with the outside world, usually via API calls. There's good news. We can have useReducer, and we can locate side effects, which is pretty dope. So I don't know how easy this is to read, but I can kind of walk through it. But so if we started looking at the kind of current world of useReducer and side effects, you imagine like a simple case where you want to get a user's avatar. So you have this reducer that has fetch avatar success, fetch avatar failure. And all that will do is kind of, it'll say like, I'm fetching, I have fetched, I have the avatar, I have fetched, I don't have the avatar. Maybe in the failure, I would set some sort of error state. And then inside the useEffect, I'm dispatching that initial action to kind of kick it all off. I'm making the fetch request, and I'm also kind of handling the success, and I'm handling the failure. But what if we could do it a different way? And yeah, imagine this if we had more than one effect. It can get messy really quickly and kind of make us feel like this. You just want to throw yourself off the couch and lay down and not code anymore. So there has to be a better way. At least I think so. So let's compare kind of the same thing we did before, except this time we'll include our side effects when we dispatch our action. So to do this, I kind of I took inspiration from Reason React, older version, which had something called the reducer component. And the reducer component essentially had a reducer built into the component. That was the stateful component of Reason React. And it was just a reducer that was built in that when you dispatched, you had 4 options. You can dispatch an update, which is just a plain synchronous update, an update with a side effect, just a side effect saying, I don't need to make any synchronous update. I just want to make an outside call, and just I want access to state and dispatch once I kind of get the return of that call. And then there's no update, which is essentially if you've fallen through to like the end of your reducer and you have not handled this case. So we can use the logic contained in the reducer instead of the useEffect, which allows us to extract the reducer, kind of use it all over the app, and not just like kind of export these effect wrapper hooks everywhere. But if we're making these calls in the reducer, doesn't that make the reducer impure? That is the kind of thing you would first think of, right? But it doesn't. We can have it both ways. So borrowing from Reason React, we return the 4 functions, as I said. And so we can have these safe, pure updates while still dispatching side effects. So how does this kind of work? Let's say we dispatch an update with a side effect. So if you dispatch an update with a side effect, what will first happen is it will be a 2-argument function. So the first argument will be an object that will just update the state immediately. And the second argument will be a callback function that receives the same thing that the reducer receives, the state and the dispatch. And since you're inside a closure, you'll also have access to the action. So you run that initial update against the first given argument, and that will immediately update the state, update your app, etc. And then essentially what is happening is as multiple actions are being dispatched, we're kind of gathering up all of these side effects. And then once we kind of flush through the synchronous updates of the reducer, we have a single useEffect that will then do concurrent updates of every side effect or asynchronous action. So sounds great. Is there anything else? What if the username or avatar size changes before the initial avatar is fetched? The request has been sent out, but we realize like, oh no, this user then logged out and another user logged in, and we don't really want to like have that kind of flash. So the side effect callback allows for a return function, which would allow you to do some kind of cancellation. In the case of fetch, you could use something like a fetch abort controller, or even something as simple as ignoring the previous fetch with a variable. So why is this kind of approach better? I just copy and pasted useEffect a bunch here and took a screenshot. So yeah, if you have a kind of a complex component that is dealing with multiple data sources, you have a couple options. Obviously, you can break these up into smaller components, but eventually you're going to run into these problems, and then you are kind of making the compromise of dislocating data that is naturally related, instead of keeping that data together and having an approach that is pretty easy to grok and more maintainable in the long term. So if we use the traditional useReducer, we run the risk essentially of something like the previous slide, a render method littered with effects and dispatches and code that's just harder to follow than it was pre-hook. You start to question, like, why am I using hooks? Am I just using hooks because it's the cool thing to do? Or is it actually making my code better? So a small demo here. Let's get this one loaded. Yeah. So we show a load there when we initialize it, and then we're showing in quote unquote avatar. But if we go here and we look at the code, what we can actually see is we have this reducer, and I kind of just decided to be cheap because I didn't feel like dealing with signals and abort controllers. So I kind of set this just variable inside the closure of the reducer. And if you go down to my render, inside my useEffect, I have a default size set to 60. I dispatch that fetch avatar, and I say if the size is not 200, set it to 200. And what that will do, if we go back up into the reducer, is here you can see that we return aborted equals true. So here we would actually want to check if we're fetching something. But this was just a demo I kind of threw together. So here we'd probably say check state.fetching avatar. If that is true, we would kind of set this aborted to true, or realistically, we would want to use an abort controller. And then we kind of ignore that 60, and we don't get that flash where you see a 60 pixel avatar and then a 200 pixel avatar in quick succession. Yeah, so like I said, the original idea came from Reason, which is now, I believe, going under the banner of Rescript. This is a project that originally started with Jordan Scales, who was the mind behind React, I guess. He, I think, did the initial implementation in standard ML. And it's It's used in production. It makes up about 80% of the Facebook Messenger code base. So it's definitely something that is reliable and used on a very wide scale. And like this hook, or I should say, I guess this hook is like that. It allows for this encapsulation of related states and effects without kind of polluting our render methods for each asynchronous state update. And then on the React side, David Capiano, who you may know from things like useState, which is super dope. And if you don't know about it, definitely check that out. Takes a slightly different approach, but achieves generally the same outcome. So ultimately, the idea can be seen as something similar to inline styles or a GraphQL query or anything that just kind of you feel belongs with the component, but is not easy to put with the component with the current tools that exist. So here we co-locate the side effectful reducer logic with pure reducer logic without sacrificing that pure reducer that could bite us if we tried to do that. I say thank you for your time. I can talk a bit more about this, obviously, and go into some more details. Yeah. So just 1 second. Right here. Screen. I'm just gonna quickly I'll quickly go kind of into how the code works more deeply. Just 1 second. Yeah, so if we go into the source here, single file, essentially what we do is for the no update, we use a symbol. And the reason that we use a symbol is so that it is universally unique. We don't have to worry about no update strings coming from kind of other places. So yeah. And then we have, you can see update is essentially just literally almost an identity function, except it wraps it in an object. Update with side effects. So something I neglected to mention is that actually you can pass in an array of multiple side effects with any side effectful update. And the same goes for just the straight side effects. And then essentially, if we walk through how the code works, what we do is we take in the reducer that you pass in, and you pass it in the same exact way you would pass it into useReducer. And we have this final reducer function where we kind of merge the state with our own state that contains side effects that we're storing internally, but that we do not expose externally. So yeah, so this is the function that would be exported to you. Yeah. So we go through here. We use a ref just so we have a constant reference to any cancel funcs, and we don't lose any of them. And then We also have compose reducers. So you can pass in multiple reducers. This is kind of something that like I'm trying to add more functionality here than even just the side effects. So getting closer to a almost component level Redux, not quite as heavy, obviously, because that's not really a road I want to go down. But I think something like compose reducers, if you have like a parent component, can be very helpful. So essentially what happens is you will pass in your code. I'm just going to do the default export here. Sorry. Yeah, so you pass in same as the reducer function, reducer initial state, and then an optional init function. We memoize that reducer. Yep. And then if the new state is not undefined, we merge we call this merge state function. And what merge state does is it checks for existing effects. And if there are any, it keeps them. And if not, it initializes an empty array. And then it checks for new side effects. So previous effects would essentially be side effects that we have queued that have not run yet, just because maybe many actions have been dispatched in a very quick amount of time. So we then just spread the existing effects and then the new effects, and you see the existing effects come first. So we want to make sure we're not running these things out of order. We check for a new state. If there's an updated state, we set the new state and update the state. And then this is kind of our internal implementation where we are keeping track of both state and side effects. And then if you saw above, this is how the side effects are run. So we have these cancel functions, which we check for when we call the side effect. We just do a simple while loop over the side effects. So the reason I'm using mutative code here is just for speed reasons. So essentially every time you run a side effect, we can check if there is a cancel function. If there is a cancel function, then we put it in that array, and executing the side effects, the return of that is a potential array of cancel functions. Here you go. In here, we check if there are side effects. If there are, we call this function run side effects, which will then return our cancels. We set the ref. We run the async effects. If there are any cancel functions, we then run those. And then return to you is just a simple state and dispatch. So on the consumer end, there's really no difference at all in the way that you might interact with the reducer. The only difference really being that update, no update, update with side effects, and just side effects. And you really only have to use those, honestly, if you want to use side effects. It will work with a plain JavaScript object. You don't really have to call the update function. It's just kind of, if you're using the library, it's an easy pattern to get into, just because you're kind of doing it for everything else. So that's all I really have on the topic directly. I'm happy to take any direct questions on any kind of side effectful collocated programming, reason, hooks, or anything like that. It's a topic with some depth, but not too much depth, and maybe there are things that I skipped over that just are in my head. So, yeah.
So I think we already still have some time, and there is one question in the Q&A.
Okay.
So, Connor, what's the benefit of this versus going something like Redux Saga? It looks like you are also use another package, Reason React, to do the reducer anyway.
So it actually, that might have been something that I kind of misconstrued. It doesn't actually use Reason React. Reason React is actually a React implementation in the Reason programming language. This is kind of just taking inspiration from the way that they handle side effectful component level updates and applying it to JavaScript React. So there's no external dependency on Reason React, just to clarify that point. And then in terms of the other point, I think the main difference is that in my experience, I found that most state is not global. It exists at a parent, grandparent level. And something like Redux Saga, you are exposing that state to your entire application. And then as soon as anyone uses it in any other part of the application, you're kind of stuck supporting it for that use case. And it kind of limits your flexibility in terms of what you can do within the component that data kind of was originally intended for. So if you're iterating on something and you're using Redux Saga and you have another developer on your team and he says, oh, we have this data, I'm going to use it for this. But then it turns out like maybe your project requirements change a little bit or something like that, and you need the data in a different way. Then you either have to essentially add another piece of data that gives it to you in your way, or work around it and massage the data. And my kind of overall philosophy on front-end development is that the front end should be doing as little as possible with data. Personally, I'm a fan of GraphQL and using BFFs to do most of the data massaging. So at the component level, you're essentially just dealing with data in the form that you want it.
Okay, that was great. Thank you, Connor. So I think now we will have some some pause in the conference, so you can grab your coffee, eat something if it's early for you, and so on, and save your questions to Connor in our Q&A session later today.
Yeah, I will be back later if you have any more questions. And it was a thank you all for listening, and it's good talking to you.
Thank you very much, Connor.
Have a good day or night wherever you are.
Same for you.
Right.
So yeah, we are receiving some questions about the schedule. So we had some changes in the between, but the next one will start on the planned time. So in and at 6:40 on the time zone. So thank you very much, and we speak later on, guys, on our next talk. Thank you.
I'll see you later. Thank you.